So in this second practice, we will apply again a linear regression, but now to a different problem. So we want to predict what will be the return on equity for the different commercial delegations of a particular company. So the data looks like this. So we have the return on equity. This is a percentage of change between for a given period, for 1 year, let's say, on the equity, so on the amount of money invested in that delegation. And then we have, so for instance, this one increase its value by 92%, this one decreased the value by -7%, and so on. So now we have, for each delegation, we have whether that office have been open for more than 10 years and the size, measuring whatever units, maybe number of people, for instance, and then the region. And we have multiple regions. We have national, North America, and then we have also European Union somewhere. And as we did before, what we will get is first the description of the numerical variable. So we see that the region return on equity, it has a mean value of about 45%, and the minimum is -40, the maximum is 120. And here we have the percentiles, and also we see that half of the delegations have been open for more than 10 years, and the average size is about 22, the minimum is 4, the maximum is 99. And we check the data types. We see that the region has been imported as an object, so we convert it to a category, and then we expanded with this one-hot encoding, as we saw in the last session. So at the end, we have the original rows plus some additional rows that are these ones, that are the ones of the region. Then yeah, and then there is another region here. Okay, so now let us explore the data. So the return on equity looks like a Gaussian approximately. Okay, that's good. Then the size doesn't look as a Gaussian. It looks more like a log normal. So we may take a logarithm. It is not necessary to do this. So predictors don't need to be Gaussian. But it doesn't make any harm if they are Gaussian either. So we will take the log size instead of the size itself. Then we plot the 4 regions that we have, so national, European, North American, rest of the world. And then more than 10 years, we see that half of the offices, they have less than 10 years, the other half have more than 10 years. Okay, so now let's try to see if the return on equity is a function of the size, or the log size. And we construct our model. The R squared is not especially good, so it is only 3%, and whatsoever the p-value is very small, so it is explaining something, not too much, but it explains something. And let us see if we can do it better. So maybe there is an interaction between the size and the age of the office. So here we have the fitting that we had, and okay, so we see that there is a lot of dispersion, and probably we will not be able to make a very good model anyway. We will see at the end. So, but when we make these fittings as a function of the age of the delegation, we see that there is a real interaction between the two. So we should include an interaction between the the age of the office and its return on equity. And here we will construct that model. So in that model we will include 3 of the regions. We know that the fourth one we don't need to include because it is a linear, there is a linear dependence between the three regions and the fourth one. And then we will use the size and also the interaction between the size and the age. Okay, so then now as we did before, also we learned that centering the variables is a good idea. So let's center them. So we construct the center log size, the center return on equity, and the center interaction. And here is just a display of how all these variables look like. And then we do the fitting. So here, this is our predicted variable, these are our predictors, and then we do the fitting. We are explaining 50% of the variance, and let us see the coefficient. So the p-value is significant, so this model is useful. And when we look at the coefficients, we see that this one here, that is the size, does not affect. So it doesn't seem to make any influence, to have any influence on the final return on equity. So there is an interaction. So this interaction, yes, it does. So the size affects through the age, but not directly. And then, for instance, it is also interesting to see these things. So, for instance, national offices, they are consistently worse. You see that the p-value is small, so this is a significant value. And while European and North America and offices, they are good, and the rest of the world, it has to be negative, because the addition of all these four has to be the contribution to the rest of the world. So the addition of these, the addition of this is positive too. It is negative. So the addition is positive, so the rest of the world is negative. And as we did before, let us check if we have problems with any one of the columns of the predictors. So we see that the variance inflation factor, they are all small except the one for the constant, but this doesn't count. And then we check heteroscedasticity. Heteroscedasticity, we see that the p-value is high, so we cannot reject the hypothesis that the data is homoscedastic. There is no dependence of the variance of the residuals on the predictors or the predicted variables, and also the residuals look like Gaussian, and the Shapiro-Wilk test doesn't reject the hypothesis. The p-value is again high enough, so we don't reject the hypothesis that that the residuals are Gaussian. So this homoscedasticity and the Gaussianity of the residuals tell us that these confidence intervals have been correctly calculated. So here we would have what is the uncertainty that we have on each one of these coefficients, and we understand now how these offices are working. So they depend on the age. So and it makes sense, because newer offices, they require a high investment at the beginning, and then they don't may pay back after some period they pay back. and then national offices are not working well, rest of the world offices are not working well, and the European and North American, they are doing good. And there is an interaction. So the when we have it was more clear here. So for all offices, the larger the office, the larger the return on equity. And it doesn't seem to be so important for younger offices. So younger offices, the size doesn't seem to matter much. So this would be all. See you in next practice.